A second method for solving systems is called elimination, or sometimes you'll see it as combination. In this case, notice there is not a variable that has a coefficient of 1, so substitution becomes more difficult. Instead, we can multiply the equations by something to get a common coefficient that we can then cancel. I'm going to work to eliminate x. In order to do that, I need the coefficients of x to be opposite of each other. So the least common multiple of 5 and 7, right here, is 35. So I'm going to multiply the top equation by 7, which gives me 35x plus 21y equals negative 49. I just multiplied each value by 7. Now I want my x value in the second equation to be negative 35. In order to do that, I'm going to multiply the bottom equation by negative 5. This gives me negative 35x plus 30y equals 100. Now I can add these two equations together. When I add them, my x's cancel. I end up with 51y equals 51. Dividing both sides by 51, I'm able to solve for y equals 1. Remember, the solution to a system has to be an ordered pair. So now I can take that value 1 and plug it into either of the original equations. I'm going to choose to plug it into the bottom one, which gives me 7x minus 6 times 1 equals negative 20, which gives me 7x minus 6 equals negative 20. Adding 6 to both sides, I have 7x equals negative 14, which leads us to x equals negative 2. Therefore, the solution to my system is negative 2, 1. And you'll notice if I plug this into the original two equations, 5 times negative 2 plus 3 times 1, I get negative 10 plus 3, or negative 7, which does indeed match my original equation. And if I plug it into the second equation, 7 times negative 2 minus 6 times 1, I get negative 14 minus 6, which is negative 20. And it does indeed work for both equations.